A research team from the Dalian Institute of Chemical Physics of the Chinese Academy of Sciences has developed all-3D printed lithium metal batteries (LMBs) with robust cycle stability and ultra-high areal energy density. This study was published in the journal Energy Storage Materials. LMBs are considered as a class of high energy density systems beyond current state-of-the-art lithium-ion batteries. Nevertheless, the uncontrollable dendrite growth and huge volume change of lithium metal anodes have raised poor cycle life. In this study, the researchers reported an all-3D printing approach for constructing ultra-high performance LMBs. The LMBs were comprised of a dendrite-free lithium metal anode with porous magazine lattices to regulate local current distribution, which homogenized the lithium nucleation, and a 3D conductive porous LPF framework cathode to achieve fast ion electron transfer channels. Due to the abundance of lithium nucleation sites and a large pore volume in the magazine lattices, the 3D printed magazine scaffolds prevented the infinite volume change and dendritic formation of lithium anodes. Furthermore, by pairing ultra-thick LPF cathode lattices with high-efficiency electron and ion networks, the all 3D printed LMBs delivered unprecedented areal capacity and energy density under an ultra-high mass loading, exceeding all reported 3D printed batteries so far.